Hello, Big Reds. We're back to Unit 6 review video part 2. Now what I've done just ahead of time is I've drawn a few of these things. As I zoom up on them and do some of the problems, feel free to draw these. I constructed them with circles, or just do it the best that you can. Right. So in this case, we have a problem like this. Let's say that this angle, this central angle right here, is 150 degrees. And I want to know what the measure of arc AB is going to be. Well, a couple ways I can do this. One, I know that the central angle is the same as its intercepted arc, so arc A to D is also going to be 150 degrees. I also know right here that this is the diameter of the circle. It divides the circle in half, so this entire semicircle is 180 degrees. So one way I could do this was I could take 180 degrees minus 150 degrees, which would give me 30 degrees. So the measure of AB is going to be 30 degrees. Right. Next problem I have here. It says, let's assume that XW and ZW are tangent segments, or tangent to the line. So what are some of the things that we know? What do we know? This is what you may be asked on a test. So what do you know? First of all, Y to X is a radius. So tangent segments are perpendicular to the radius, so this must be a 90-degree angle. This also Z must also be a 90-degree angle because YZ is perpendicular to WZ. Okay. Since these are both 90 degrees, they add up to 180 degrees, and any quadrilateral adds up to 360 degrees. That's the sum of the interior angles. So I could take 360 minus 180 gives me 180 degrees left for these two angles, angle Y and angle W. These two have to add up to 180 degrees. So if I was to pick this angle Y was 160 degrees, I could take 180 minus 160 to give me 20 degrees. Again, these two angles must add up to 180 degrees. Okay, next, let's say we have another tangent segment. Let's say AC is tangent to the circle. I do know that if it's tangent to the circle, it's perpendicular to this radius right here. And if I wanted to know the length of AB, what is that going to be? I could use Pythagorean theorem, right? And again, the right angle always points to hypotenuse, so I could take x squared plus 12 squared equals 13 squared. X squared plus 144, that's 12 times 12 is 144, equals 13 times 13, which is 169. Subtract 144 from each side. I'm left with x squared equals 25. Take the square root. X equals 5. So that means AB must be 5 centimeters long. All right, next, we did a few problems with common tangents. So I didn't draw these obviously with a compass, but I just sketched them briefly so you could see. All right, how many common tangents would this have? So we're going to look for the number of common tangents. Remember, a common tangent is a tangent line that is tangent to both of these circles. So that means it intersects both of these circles in one point each. So I could draw one like this. One like this. And one like this. So these two circles would have 3 common tangents. All right, these two circles I have one common tangent at the top, one common tangent at the bottom. I can't draw one through the middle. The reason is because I'd intersect the circles more than one time, so I'd have a secant line instead of a tangent line. So these two circles have two common tangents. And down to these two circles right here, I can draw one here top. I can draw one at the bottom. I could connect these right here. There's a third one. And here's a fourth one. So these have four common tangents right here. All right, now I'm going to continue going on. I'm going to start talking about arcs and sectors. Remember, I want to remind you about the pie and the cake and all that good stuff. I don't want to make you too hungry, but just to give you a visual. So, let's talk about, say I have a very large slice of pie right here. Say this is CD. And let's say my slice of pie represents 110 degrees. And I want to, first of all, I want to find the area of the shaded region. That's what I want to do. Okay? So first thing I want to do is I'm going to use my sector area formula. You remember sector area over the area of the whole circle, which is pi r squared, is equal to the angle of the sector over 360 degrees. Just a real neat proportion that you can use here. So, I don't know what my sector area is. I'll make that x. I know pi times, I need a radius. I don't have a radius. Radius will be given to you. So let's say the radius is 5 centimeters. This is, 5 centimeters is fine. That's a real small slice of pie, but that's okay, 5 centimeters. And our angle is 110 degrees over 360. Now to solve this, I'm going to cross multiply, take pi times 5 squared times 10, and divide it by 360. And that's going to give me the area of my sector, or x. You can round this to the nearest tenth is fine. So let's say 5 squared, order of operations. 5 squared is 25. Multiply it by 3.14, or you can use pi. Multiply it by 110 and divide it by 360. That gives me about, it rounds I think up to 24.0 square centimeters of pi. Pi, sounds good, huh? All right, now let's go over the other side. Let's say I want to find the length of this crust, the crust of the pie. So that's going to be an arc length over 2 pi r, which is the circumference formula, equals the angle over 360. So again, similar formulas, solved a little differently. So I don't know my arc length. I'm going to leave that x over 2 times pi times the radius, which is 5, equals the angle, which is 110 over 360. I'm going to cross multiply and divide. So should get about, for the arc length, 9.6 centimeters. Now remember, arc length is a length, so it's just in centimeters, versus the sector area, which is an area space it's filling up, so it's square centimeters. Make sure you see the difference. Okay. All right, now we have one more part 3 coming up. So open up the other part and let's get started.